everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. We have taken the topic for discussion is problems on line integrals. In detail, we will discuss about definition of line integrals, problems based on line integrals. That is, let f bar of r be a vector function which is defined and continuous along the curve C. This is a curve that is C. A is the starting point, B is the ending, and it's a curve named C. There is a point P on the curve. These components of the vector function f bar of r along the tangent at P, that is a line which touches the curve at one point, that point is P, is f bar of dot product of vector point function and t vector. This t vector is nothing but the ratio of r vector dr by ds. That is, the ds, it's nothing but the length of the arc. Now, the integral, the product of dot product of f dot t ds taken along the curve C, which is called the line integral of f along C. We can write this as, that is integral a to b. Here we can see the figure. F dot t ds. Our t, how we defined, it's nothing but dr by ds. This ds getting cancelled. Then we obtained integral over c f dot dr. This is the formula for line integral. Now, the first problem, what we are going to focus here is compute the line integral y square dx minus x square dy round the triangle whose vertices are. That is the function which is given as y square dx minus x square dy round the triangle whose vertices are 1, 0, 0, 1 and minus 1, 0 in the xy plane. Now, with this help of the coordinates, the vertices, we will draw the diagram. That is x-axis, y-axis, here origin, that we named it as O. The vertices, the vertex here minus 1, 0. So minus 1, that is there is a point minus 1 in x-axis. Here we pointed, that we named it as A. And so this point we plotted, that we named it as A. Another one, that is 1, 0, that we plotted here in the positive direction because our x is 1. That name we have given B. So B of 1, 0. And one more, the vertex, the coordinate point is 0, 1. That is x is 0 and y. The point 1 and on y-axis, that is C of 0, 1. So all these coordinated points are we plotted and we joined it. So the name A, B, C, we have given the name with the help of what is the condition which is given in our problem. We have drawn the diagram, and ours is now xy plane. So this is the diagram. Now our A, the coordinate is -1, 0. Our B is 1, 0. C is -1, 0. The equation of AB. Now we can see from A to B, which is in x direction it moves. That is -1 to 1 it moves. Then what about y? Y equal to 0. That's what it is written. The next one is equation of BC. That is, our B is 1, 0. Our C is C, 1. That is, here one point is there, 1, 0. Here another point is there, 0, 1. 2 points are there. And the line which joining the 2 points, what is the equation of that line? That is, according to the formula, that is the mathematics, analytical geometry. The formula is y minus y1, which is equal to y2 minus y1 divided by x2 minus x1 of x minus x1. So x1, y1. Here we have taken our B of 1, 0. This is playing the role x1 and this is playing the role y1. The next one, the C point, it is there, that is 0, 1. This is playing the role x2 and this is playing the role y2. So we are going to substitute these values in the above formula. So we did the substitution, that is y1 is replaced by 0 because we know it, our y1 is 0, and y2 minus y1, they are replaced by 1 minus 0. x2 minus x1, they are replaced by our x2. Here, our x1 is here. They are replaced by 0 minus 1 and x minus x1. That is x minus x1. Our x1 is 1. So what are the values of that x1, y1, x2, y2? We substituted in our formula equation of a straight line passing through 2 points. That formula we substituted. Now the left hand side we obtained y. What about right hand side? 1 minus 1, 1 divided by minus 1. So here put together we got it minus 1. Minus 1 into x minus minus plus. And we brought it, the minus x, towards the left position. We obtained x plus y equal to 1. Now, so the equation what we obtained is x plus y equal to 1. So now, this is our vertices, the points. Now we wanted this equation. The point is C, 0, 1. Here the point is minus 1, 0. So the 2 points are there. The equation of the straight line, the equation of the line passing through 2 points, that is our C and A, the formula which is ready, our x1, y1, this 0, 1, that is our C at the point C, 0, 1, we have taken as x1, y1, and A minus 1, 0, we have taken as x2, y2. We substituted, that is y minus y1, our y1 is 1, y2 minus y1, this is our y2, this is our y2 minus y1, so we substituted 0 minus 1, x2 minus x1, that is substituted in the place minus 1 comma 0, this is our x2, here x1, in this place x minus x1, that is x minus x1, here our x1 is 0. So all these x1, y1, x2, y2, the corresponding places we substituted, we obtained, this is y minus 1, minus 1 divided by minus 1 is 1, 1 into x, x. So we are bringing the x towards this side. So y minus x equal to 1. So this we obtained from C to A. The equation of the line is y minus x equal to 1. Using this formula, the line passing through 2 points, we obtained y minus x equal to 1. So the next one is, so it's ready and we know it, this BC, the equation is x plus y equal to 1. Now the formula for the line integral is, that is integral over C f dot dr. This is our function which is given. This problem only we are solving, for which the function which is given y square dx minus x square dy. So now from A to B we are moving the line integral along AB plus the line integral along BC, the line integral along the CA. We started at A point and the terminating point also A. So both the starting point and terminating point coincides. It is a closed curve. That's what here the symbol also it is there. The line integral, the closed one, the bounded region should be closed. So now the finally AB along, BC along CA. So three line integrals finding their sum we have to do it. So now we can see it along the line AB. So along the line AB, we can see it here. From A, we are moving towards that direction, x direction we are moving. So the point is A minus 1 comma 0. That is x point is minus 1. Here is 1. From minus 1 to 1, we are moving in the x direction. The points name are from A to B. So we are going to evaluate the integral minus 1 to 1. That is x varies from minus 1 to 1. Then what about y? Y we can see it here. Y equal to 0. That's what it is written. So dy is also 0. So x varies from minus 1 to 1. This is our function, that is integral over AB. The given function is, the complete line integral is integral over C f dot dr. The f dot dr put together in the question which is given y square dx minus x square dy. The integral over C we divided into 3. Along AB direction we are. So we are moving from minus 1 to 1. That's the reason here it is written x varies from minus 1 to 1. When x varies from minus 1 to 1, the y value is 0, dy equal to 0. So thus y equal to 0, we will substitute here. Dy is 0, so this is completely vanished. And y also 0, so if we are substituting here, the totally we got it here, taking these values, complete our the function substituting, we got it 0. So the first here from a to b, the result we got it 0. That's what it is mentioned here. So the next one is, we can see it very well. We completed from A to B, we obtained the result 0. Now we are at the point B. From B to, we are going to move to C. Now, x varies from 1 to 0. So we can see it here, x what I am putting, the coordinate first one, 1 to 0 it moves. Here the equation of the line is x plus y equal to 1, from which we obtained y equal to 1 minus x. Both the sides we will do the differentiation, that is dy equal to minus dx. So this is our function from which this we are going to substitute. That is y what we obtained 1 minus x. We can see it very clearly here, 1 minus x. The square is written as it is, dx is as it is. Minus x square, there is no change at all, just we have written. Dy it's nothing but minus dx. These two, we are along BC. So, x varies from 1 to 0. Now, this minus put together plus. So, x from 1 to 0, 1 minus x the whole square dx plus x square dx. This we have to do the integration. Now, 1 minus x the whole square, simple integration, integral over x power n dx is x power n plus 1 by n plus 1. Our n is 2. So 2 plus 1, 3, here also 3. Then how we obtained this negative sign, that is the coefficient of x is minus. So minus into 3, minus 3 we obtained. So we completed this part integration. Similarly, x square integration, that is x cube by 3, 1 to 0. So we are substituting the limit values. That is our upper limit is 0. In the place of x we are substituting here 1 minus 0. So 1 by minus 3 we obtained. When we are substituting this lower limit, 1 minus 1, it is vanished. So this part only we obtained minus 1 by 3. Here coming to the picture of this, upper limit is 0, x place we are substituting, totally it is vanished, minus, that is the limit formula, that minus. X place we are substituting the lower limit, that is 1 by 3. So this put together, the result is minus 2 by 3. So we obtained this BC, the result is minus 2 by 3. Already we obtained AB, the result is 0. Now the leftover, the side is, we are now C, from C to A we are going to move. So we can see it here. So along CA, we know it, this is our equation of the line, that is y minus x equal to 1. Just minus x brought it here. That's what it is written, y equal to x plus 1. Both the sides we are doing the differentiation, that is dy equal to dx. X varies from 0 to minus 1. Easily we can see from the figure, that is x 0, here minus 1. Very simple one. So x varies from 0 to minus 1. This is our given function. Along CA, we are evaluating the line integral. This is our function. So in the function y, we are replacing by x plus 1. It is replaced. The square which is written as it is, and this minus is as it is, x square, and dy, it's nothing but dx. So now here 1 plus x the whole square, it's nothing but the integration, simple integral formula, n is 2. So 2 plus 1 by 2 plus 1. So 1 plus x power 3 by 3, 0 to minus 1, minus this minus, here minus, x square integral is x cube by 3, 0 to minus 1. So now we will substitute for this first one, upper limit is minus 1. When we are substituting x place minus 1, 1 minus 1, it has become 0. The lower limit is 0. We are substituting the place x is 0. It has become 1 by 3. This is limit formula. Next, here upper limit is minus 1. X place we are substituting minus 1. The whole cube, it's nothing but minus 1. Already outside minus is there. So it has become plus 1 by 3. And the lower part is 0. X place substituting, it has become 0. So the limit formula, we have to be very careful. Upper limit value minus lower limit value. So now the CA, this direction, we obtained the value 0. So A to B value we got 0, and B to C we got it minus 2 by 3, and C to A we obtained 0. So we can see this one. This is our line integral formula, integral over C f dot dr. This is our function y square dx minus x square dy. Now along AB plus from AB, along BC, along CA, completely we did. That is, along AB, x direction, x varies from minus 1 to 1, and here also x varies from 1 to 0. Here x varies from 0 to minus 1, and we evaluated the integrals. We obtained the result, that is, along AB, we obtained the result 0. Along BC, we obtained the result minus 2 by 3. And along CA, we obtained the result 0. So, which is nothing but minus 2 by 3. So, the next problem we will move, evaluate the line integral. That is integral over C, x square plus xy of dx plus x square plus y square of dy. This is our given function which is given, where c is the square. That is, what is the bounded region condition which is given if we joining the geometrical figure, what we are going to get is square. That is the meaning of this question. The function which is there, it should be a closed curve. So evaluate for this function using this bounded region conditions. Evaluate the line integral. So now what is given in the question first we will, for which first we are writing line integral formula we are writing. That is, formula of line integral is here, which is written integral over c f dot dr, which is equal to, plus four directions are there, AB, from BC, and CD. From D we are moving to A. So we started at the point A, we ended with the point terminating point A. So starting and terminating coincides. It's a closed curve. So it is fit for line integral. Now we have to evaluate. First, using this condition, we have to draw the geometrical figure, that is the square first we have to draw. So now we can see that origin we have named it as O, x-axis, y-axis. Yes, because x which is given plus or minus 1, y which is given plus or minus 1. That's what which is given in the question. So x equal to plus or minus 1. So plus 1 is there, minus 1 is there. The meaning is plus 1, the point which lies on x-axis, minus 1 which lies on x-axis. Same, y equal to plus or minus 1 which is given. Same, plus 1 which lies up, minus 1 which lies down. X plus 1 this side, minus 1 this side. This is all what we studied in lower classes. Now, so we can see the points, minus 1 which is given here, and 1 which lies on x-axis, and there is a point even on y-axis, that is here plus 1 in y-axis, minus 1 on y-axis. So all these points put together, x comma y. So minus 1 comma minus 1. This point 1 comma minus 1. So we can see it here, the square shape. That is, when minus 1 which is plotted here, and towards that here minus 1 is there, put together this is minus 1 comma minus 1. Here the point 1 is there on x-axis. Here minus 1 is there, straight to that. The point we named it as B. The coordinate is 1 comma minus 1. Here the point is 1 is there on x-axis, and there is a point on y-axis, 1 is there, because this up it is positive direction of y-axis. The down one, it is a negative. The points will be there on y-axis. So here y, the positive 1 is there, here the 1, here. This put together, the coordinate is 1 comma 1, that we named it as C. Here the point is there, here minus 1 is there, x-axis, here straight to that, this is a positive y equal to 1. So x equal to plus or minus 1, y equal to plus or minus 1. These 4 points we plotted, we joined it, we got the geometrical figure square. So we can say it very well here. That is, from the figure itself we can say that is x equal to here 1, where I am putting the tick, and y equal to 1, just I am joining. So you can say it very well, y equal to 1. And x equal to minus 1, here also we can see it. So x equal to minus 1. So we can see the arrow marks. That is, we are starting from A, the arrow mark is moving to B. From B to the arrow mark which is there, it moved to C. From C to the arrow mark direction, which moved to D. From D to, we are moving to A. It is a closed curve. We can find the line integral. Now, this one, so we can see it here. That is here, which is given here along the line AB. That is, here is there along the line AB. We can see very well, that is x which moves from minus 1 to 1. That's what which is written here. Next, this is our given function. So integral over AB, f dot dr is our line integral. So when it moves from A to B, you can see what I am circling the value, that is minus 1 to 1, which is given here. When it moves in the direction of x, so the particle at a distance from A to B, it is moved. What is the value? From where to where? The name is from A to B, it is moved. The value is from minus 1 to 1. That's what x varies from. Then what about y? We can see it. The y is equal to minus 1. That's what it is mentioned here. So the function is here. Now, in this, we are going to substitute y equal to minus 1. Our dy, which is equal to 0. So the dy, which is equal to 0, here completely it is vanished. In our function, we are substituting. Completely it is vanished. And we are going to substitute y place minus 1. This x square is as it is. This minus we are replacing by minus 1. So x into minus 1, it has become minus x, which is equal to, we will do the simple integration, that is x square. The integration is x cubed by 3. That is a formula. There is a x power n dx, which is nothing but integral of that one. X power n plus 1 by n plus 1. Our n is 2. So 2 plus 1 divided by 2 plus 1. So x cubed by 3. This minus, there is no change at all. Minus x power 1, n is 1. So x square by 2. So x varies from, that is, along AB minus 1 to 1. So our lower limit value is minus 1. Our upper limit value is 1. So in the x place we are going to substitute. So we are concentrating, we are focusing the upper value 1. So it has become 1 by 3. This minus as it is 1 by 2. Upper limit job is over. So limit formula, upper limit minus lower limit. Lower limit is minus 1. X place we are substituting. So minus 1 the whole cube. So minus 1 by this 3 as it is. Here minus as it is. Minus 1 the whole square, 1. This 2 is as it is. So we can, the first one, we are simplifying. We got it taking the LCM minus 1 by 6. And here we are simplifying. We obtained minus 5 by 6. Already minus is there. So plus 5 by 6 put together 4 by 6. Then the value is 2 by 3. So from A to B, the x direction we moved, we obtained the result 2 by 3. Now, from here we moved, now we are at the point B. From B to C we are moving. That is, we are moving in y direction. So when we are moving to y direction, y varies from where I am putting the tick. This is the value. That is from minus 1 to 1 in the y direction we are moving. So y varies from minus 1 to 1. Then what about x? Just I am circling x equal to 1. That's what which is written here. X equal to 1, then dx equal to 0. So we can see it here. Very clear picture. Y varies from minus 1 to 1. So this is our function. And we are along BC, f dot dr, integral over minus 1 to 1. Now we are going to substitute, that is a dx which is equal to 0. So this one completely vanished. And x place we will substitute 1. So it is becoming 1. 1 plus y square of dy. Then integral we will do it. dy integral is y plus y square, the integral is y cube by 3 minus 1 to 1. That's what which is written here. Now we will substitute the limits. The upper limit is 1. You can see it. So 1 plus 1 by 3. Limit formula sign. Minus 1 is our lower limit. Y place we are substituting minus 1. And minus 1 the whole cube minus 1 divided by 3 as it is. Simplifying. The first one simplifying 4 by 3. And this simplifying minus 4 by 3. Already minus is outside. Plus 4 by 3 put together 8 by 3. So now along BC we obtained the result 8 by 3. So now we are at the point C. From C to D we are going to move. So we are moving in the direction of x. Then x varies from C we are moving. This point we have to be very careful. From C we are moving. So 1 to minus 1. You can see it. X varies from 1 to minus 1. Then what about y? I am circling. So y equal to 1. That's what it is written already. So when y equal to 1, dy, the differentiation of constant is 0. So we can see the function which is given here, in which we are going to apply these values. So dy which is equal to 0. So it is completely vanished. And y we are going to remove in the place, replacing by its value 1. So we obtained this. We are in the direction of CD. Along CD, the line integral we are evaluating. So x square plus x, simple integral. X square, the integral is 2 plus 1 by 2 plus 1. So x cube by 3. X power is 1. 1 plus 1 divided by 1 plus 1. So x square by 2. So 1, 2 minus 1. That's what here which is written. So now we will concentrate our upper limit, that is minus 1. So we are substituting in the place of x. In the place of x, we will substitute x value minus 1. So we substituted, that is minus 1 divided by 3 as it is. Plus minus 1 the whole square, that is 1. 1 divided by 2. Upper limit work is over. Minus lower limit. Lower limit x place we will replace by 1. So 1 by 3 plus 1 by 2. So simplifying, the first one simplifying, taking LCM, we obtained 1 by 6. This minus as it is. This second one, we have taken the LCM, 5 by 6. So the simplifying, we obtained minus 4 by 6, the lowest form of the fraction, which is minus 2 by 3. So along CD, we evaluated, we obtained the result minus 2 by 3. So the last one, at present we are at the point D. So from D to A we are moving. That is, we are moving in the direction of Y. Vertically, in the Y direction we are moving. Then Y varies from where I am putting the tick in the coordinate, the point regarding Y. From 1 to minus 1 we are moving. Then what about X? I am circling the value. That's what x equal to minus 1. Here already we mentioned it. So when x equal to minus 1, the differentiation is, x differentiation is dx, the differentiation of any constant which is 0. So we can say it, that is y direction. From D to A we are moving, we obtained 1, 2, minus 1. So this is our function. In the function, we are going to substitute this dx equal to 0. Completely, this is vanished. Next, x equal to minus 1. Here we are substituting. So minus 1 the whole square. It's nothing but 1. So 1 plus y square dy. That is from 1 to minus 1. Here dy, that is y square, that is y cube by 3, from 1 to minus 1. So we are going to substitute in the place of y the upper limit value minus 1. So minus 1 and minus 1 the whole cube is minus 1. The 3 is as it is. Upper limit, the value minus 1, work is completed. This is a limit formula, negative sign, between upper limit and lower limit value substitution. So now the lower limit value is 1. We will substitute in the place of y. Then 1 plus 1 cube by 3 is 1 by 3. So this first one, when we are circling, we obtained what is the circled one. The value is minus 4 by 3. This value is 4 by 3. Outside already minus exists. So minus 4 by 3 put together minus 8 by 3. So we can see very well here. That is, when it moves from D to A, we obtained the value minus 8 by 3. So put together we can see it very well. That is, here we can see the line integral. The formula is that is the integral over AB f dot dr, that is along AB, along BC, along CD, and along DA. The complete one, which is, we already named it as equation 1. So along AB, we obtained the value 2 by 3. Along BC, we obtained 8 by 3. Along CD, we obtained minus 2 by 3, and DA minus 8 by 3, and this getting cancelled. So the result is 0. So we will come to a conclusion of this topic. That is, first, this is the line integral formula. This line integral formula, that is A, B, C, the vertices which are given, with the help of these vertices, we have drawn the geometrical figure. We got a triangle, and with the help of the formula, the equation of the line joining 2 points, we obtained x plus y equal to 1, and for C to A, we obtained y minus x equal to 1, and along AB, that is x direction, x varies from minus 1 to 1, we evaluated the integral, and from B to C we evaluated, and C to A finally we evaluated. So for AB 0, for BC minus 2 by 3, for CA 0. So the first thus problem, we obtained the result minus 2 by 3. So one more problem we discussed it, that is, we have taken this line integral formula purpose. This function we have taken, that is x square plus xy of dx plus x square plus y square of dy. This bounded region condition which is given, x equal to plus or minus 1, y equal to plus or minus 1. With this help, first we plotted the points and we joined, we got the geometrical figure square, and we know the directions, which is in the positive direction, forward direction, and it should be a closed curve. That point also we noted, and we obtained the result from A to B, x direction minus 1 to 1, and BC y direction, y varies from minus 1 to 1. From C to D, x direction, x varies from 1 to minus 1. From D to A, y direction 1 to minus 1. For AB direction 2 by 3, for BC 8 by 3, CD minus 2 by 3, DA minus 8 by 3. Final the result, adding all the 4, AB plus BC plus CD plus DA, which is nothing but our complete closed curve. The result is 0. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.